Okay, so hello everyone, and welcome to this journey through the innovative landscape of low-power wide area network. So today we will explore how LoRaWAN is revolutionizing the way we connect devices to communicate over long distances. From device deployment to deployment strategies, we will see how to reduce time to market to make our product smarter and more efficient. So, take a look here at this picture. It's a city with green trees, tall buildings. So, a place like many other, like where we live, we work. But there is something special going on here, something that we cannot see. The city is full of smart technology that can help us every day. And today, we're going to see how LoRaWAN is helping and bringing value by collecting data. Data that can help us to do things better and to save time. Nowadays, people talk a lot about AI and how AI can do amazing things. But to unlock its full potential, AI needs data. AI algorithms need data to learn from. And LoRaWAN technology allows smart devices to collect this information to feed the AI algorithm. So let's dive in and see more in detail how the technology combined with smart components from ST makes a difference in our daily life. So now I'd like to ask you a question. Looking at these three IoT use cases, asset tracking, environmental sensor, gas and water meter, what do these applications have in common? So these applications might seem quite different at the first glance, but they share some important features. They all send out tiny bit of data now and then. They run on batteries, and they can be placed pretty much everywhere. So for that kind, long battery life is not just a nice feature, it's essential. Then we talk about long-range connectivity. When we talk about long range, we are not just talking about long distances. We are talking about signals that can go through the walls to connect with smart building sensors, or to go underground to address water and gas meters, or again, to go through the noisy, crowded city environment to connect with IoT sensors and track devices. Then, we cannot forget about security here. With the coming up regulation about cybersecurity, as we are talking about data, privacy is a big concern here, so security is something we cannot forget. And LoRaWAN is really addressing these three main use cases. So let's dive in now and look at some specific use case to see how this is addressed. So the first use case I would like to show you today is about IoT sensor for environmental protection. When we talk about fighting global warming, we often forget about the silent giants that do so much for our planet, trees. And monitoring their health is crucial. And that's exactly what our customer ePlant is doing with their tree tag system out here in California. They are actually putting together a smart setup using LoRaWAN to keep an eye on growing condition of the trees and vineyards in order to protect them. So looking this a little bit more in detail on the sensor side, so the sensor measures actually the tree diameter, and to monitor its growth over time. But it does actually more than that. It combines some advanced sensor to keep an eye on how much water and light the tree gets. It checks how well it's capturing carbon, And then it sends all this valuable information straight to the cloud for analysis. One of the coolest things about this sensor is that it is solar powered. So it runs without battery, using supercapacitor. And this is really useful for such kind of out-of-the-way trees that are difficult to access. You cannot imagine to have a truck going there replacing the battery. So solar panel is really important for such use case. And then at the heart of this device, there is an ST component, a system-in-package component, the STM32WL a system-in-package module recently introduced by ST. And let's see why ePlant selected this product for their system, for their ePlant system. First, this is all about integration. Because to achieve the smallest footprint possible, we have integrated into a single device all the RF bill of material. So when I say bill of material, I mean all the RF components that are in between the radio and the antenna, so including the matching filters, the harmonic filters, the balloon, also the crystals and the switch. All of that has been integrated into a 10 by 10 millimeter footprint package, the STM32WL5M. And integrating so many components into a single package is also a way to reduce the effort for the R&D design. It's a way that allows customers to save time and to speed up their time to market, because the module has been already fine-tuned and it follows the FCC CE regulation to speed up the time to market. If we look closer at this module and we look a little bit more on the feature side, this module is based on a dual-core approach. So this one allows customer to manage the LoRaWAN stack on one core and the application on the other core. So what does that mean in practice? It means that the module can analyze data locally and send it only when it is required, and send only the relevant information when it is required. And this is quite useful to reduce the amount of data in order to save wireless bandwidth and to conserve energy. So dual core, yeah, it's a way to really conserve the energy and to also to integrate, to make sure that the device can work as a standalone mode, so without the need of an external host, contributing here again on reducing the bill of material. Okay, so I've talked quite about the features, and I'd like to show you more about the radio of this module. The radio inside this module, as I said, certified CE FCC IC in a way to deploy it in Europe, in America, and also in Asia Pacific, supporting the full high frequency band. And as well, in a way to fulfill with the power output regulation, it supports two power outputs. So one low power PA that can be used in Europe, for example, to reduce the power consumption, and one high power PA that can be used in the US, where the regulation allows to go above at higher power outputs. So now we have seen the environmental sensor application. I'd like to move to the next one, the next use case that I want to show you today. And for that, let's travel to Singapore. If you have been already to Singapore, you may have visited the nature park called Garden by the Bay. And if you've been there, you cannot miss its super trees. But you may have missed something. You may have missed that all over the park, there are LoRaWAN sensors that helps to monitor the water power, the water consumption, and the energy usage all over the park. And this is possible thanks to our customer, Syncom, that do exactly that with their metering solution. They are actually proposing a metering solution which is an add-on, a meter add-on that can be put on top of any mechanical meter in a way to connect the meter to the cloud on existing installation. On top of that, they are doing also some leakage detection, so to act quickly when there is any leakage to protect this precious resource, water. And they are able also to detect the aging of the meter and to prevent fraudulent activities. Inside this meter, there is a device, the system on chip from ST, the STM32WL. And about that, I wanted to show you a little bit more about how to achieve long battery life, which is critical in a meter application that runs on a battery for more than 10 years from a non-rechargeable battery. So most of the time, the MCU inside a meter is in standby mode, so essentially asleep. In fact, it is waiting for its next transmission slot 99% of time. And during that period, it only needs to retain a portion of its memory and to keep counting a real-time clock in a way to wake up when it is necessary. So, and that's exactly what we optimized on the STM32WL in a way to have a low power mode, able to achieve the lowest possible power consumption with 32 KB of RAM and the RTC, so the real-time clock, in a way to wake up the MCU when it is necessary. Okay, I'd like to leave you here with an overview of the ecosystem of this STM32WL, because ecosystem for the developers is really also a way to optimize the time to market. And the WL is fully integrated inside our development environment, CubeMX. So that allow designers to quickly wire and debug their application using the graphic user interface and to quickly set up a new device. Certification, so we have talked about the certification related to the radio, CE, FCC, IC, but on top of that, the module is fully LoRaWAN certified. And then comes with prototyping. So prototyping in a way to quickly create a demonstration based on this product using sensors, using external devices. Okay, so we went through this innovative journey through LoRaWAN use cases. We have seen how our customer ePlant is doing IoT sensors and reducing the footprint as much as possible of their IoT sensor. We have seen as well how to address low power requirements on metering use cases and how to combine LoRaWAN value and ST solution to address these two specific use cases. Now, I would like to invite you to come to our booth to have a look to our demo. We have the STM32WL5M, the module live demo, showcasing sensor connectivity to the cloud. And we also have this module able to address LoRaWAN relay, which I personally think will bring LoRaWAN to a next step, extending the range of LoRaWAN, addressing new use cases in a way to, for example, to go through the walls to address IoT sensors in buildings, or in a way to address better water, gas meter, go underground. And that's a demo we have with both STM32WL at the end device and at the relay side. Okay, so thank you for listening and for joining me in this innovative journey through LP1.